today we are going to talk about relationship between voltage and current. So we talked in our last lecture about voltage and current, right? So we talked about voltage and current quantities in my first lecture, and today we are going to find out what's the relationship between them. And the real answer to that question is there are many. There's just not one relationship. So it's depending on what type of component we are using. So let's take a look at 3 to 4 different types of devices or components. The first is resistor, then we will see capacitor, let's talk about diode, thermistor, and then photoresistor. Let's talk about these 5 components. So in the resistor is if you want to define voltage and current relationship in the resistor, it's like V is equal to IR. That's how the current and voltage is defined. So basically V is proportional to I, or I is proportional to V. It's one or the other way. There is a linear relationship between voltage and current. In the capacitor, current is proportional to rate of change of voltage. Remember, that's how the capacitors are defined. In the diode, current and voltage has exponential relationship. That's how diodes work. Remember that we will be studying these devices little bit more detailed manner in the next upcoming lectures. Here I'm giving you just an overview, okay? And thermistor and photoresistor, if you have observed, both of these are resistors. There is a resistor word in their actual name. So these are resistors, but their resistor is dependent on different quantities. So for thermistor, resistor is dependent on temperature, like it has either positive or negative temperature coefficient, which is written as NTC, which means that if temperature goes on increasing, the resistance goes on decreasing. That's what it means. That's negative temperature coefficient. Photoresistor has a resistance which depends on the light. That means photons. More the light, I think the resistance increases. I'm not sure about that, but it has some resistance dependent, light dependent resistor. It's also known as LDR. That's a photoresistor, and these devices are like used in widely manner. Along with this, there are other devices which I haven't talked. There are 3 terminal device. It's called as MOS or BJT. There are 2 of those. Maybe you don't know much about these devices right now, but this is just an overview, like what are these. And suppose there is this base, there is this emitter, there is this collector. So this is a BJT. This is a BJT where the voltage given at point B and E, which is this, and voltage given at point C and E, which is collector and emitter. It defines the current flowing through collector and emitter. So how they are defined, how they are related to each other, this we will see in next lectures. I am not sure if I am going to talk about BJT in this lecture, in this course itself, but let's see. So purpose of this slide is just to give you introduction to different types of resistors, capacitors, diode. There are, just to let you know that there are these devices which has different IV characteristics, different IV relationships. So today's lecture we are going to talk about specific about resistor. I want to change color. So resistor, let's write a big title. So resistor is, as its name suggests, resistor has a characteristic of resisting the current. Okay, it's gonna resist the current. That's a resistor. Let's take this example. Suppose we have copper bar. It's a big copper rod. We have aluminum. Suppose that this is an aluminum bar, and then suppose we have plastic, okay, and bar of a plastic, and suppose we apply same voltage across each of the devices. We apply 5 volts here and 0 volts. We apply 5 volts on this side, again 0 volts. We apply 5 volt here and 0 volt, and as there is a potential difference of 5 volt and which is applied across the terminals, as we saw in the last lecture, there is a current flow, right? Current I1 flows through this device, current I2 flows through this device and current I3 flows through this third device, which is a plastic. So can you comment about this current I1, I2 and I3? Well, although we have applied same voltage across three different material of bar, these currents are not going to be equal to each other, right? This is why. That's the question, right? That's because if you apply 5 volts and if you want to know what current is flowing according to the equation of the resistor, which is VIR, if you want to know I, we need to know, so I is equal to V by R. We need to know R, which is the resistance, right? That's a resistance. It's a property, it's a resistance of a material. So resistance of copper is different, resistance of aluminum is different, resistance of plastic is way different. And if you ask me, there will be no current through the plastic, right? Because plastic is not a conductor. That means it has lot of resistance. Where copper and aluminum has very less resistance, there is lot of current going to flow through this. So that's how defined a resistance. Resistance is a property of a conductor, semiconductor, insulator. Each of these materials has some resistance across it, and depending on its resistance, it allows the current to flow through it. So let's see this device or component called as resistor. Resistor is a devices, or we call it component, you see in every electronic circuit. Resistors are generally look like very small resistance, look like this, and they are made up of, I think, carbon metal thin films, also carbon films. Resistance values varies from 1 milliohm to like 1 mega ohm, hundreds of mega ohm. That's how the resistors, that's what resistors are. The unit for the resistance is ohm, which is something I guess you should know. Ohm, which is denoted by like this. Ohm is, this is a symbol for ohm. And 1 ohm resistance is when 1 volts of voltage is applied across a conductor, which creates a current of 1 amps. That's, this equation is R is equal to V upon I. So resistance is kind of taken for granted quantity. You can see the resistance in each and every circuit. Okay, it's there in each and every circuit. Resistance is there, resistors are there. At the end of this lecture, or maybe in the next lecture, I can show you the actual resistors and different types of resistors. So that's about this slide. So let's go ahead. So while talking about the resistors are they are generally denoted like this, or this. That means the current when goes like this, this is not really hard way for current. That means there is some resistance, and then it will come R. Okay, there are two ways in a circuit to connect resistor. Okay, first, suppose there are two resistors R1, R2. The first is R1 and R2. They can be connected in series. That means I connect R1 first and then I connect R2. So this is R1, this is R2. Suppose this is 1 ohm, this is 10 ohm. So total resistance of this circuit is 10 plus 1, which is 11 ohms. And second type of connection is R1 and R2 are parallel. That means they are connected in this way, parallel to each other. Both the ends are connected together, and this is R1, R2, and their equivalent resistance looking into this side is 1 upon R1 plus 1 upon R2, 1 by this. So this is generally R1 R2 divided by R1 plus R2. That's equivalent resistance of two parallel resistances, and this is generally given as R1 parallel R2. This is how we write, which is equal to R1 R2 divided by R1 plus R2. That's parallel resistors. So if you see a complicated circuit, you will always able to distinguish two types of resistor connections. One is a series connection, other is a parallel connection. So this can be R1, R2, R3, R4. You can write this equivalently: R equivalent of these two, R equivalent of this parallel combination. Now let's see a trick to find out, equivalent resistance of a parallel resistors combination. Suppose that there is a resistance R1 and there is resistance R2 connected parallelly. R1 is 10 kilo ohms, R2 is 10 kilo ohms. So if you do the math, equivalent resistance is R1 R2 divided by R1 plus R2, which is 10k 10k divided by 10 plus 10k, right? That is 100k square divided by 20k, which is 5k. Similarly, if you take three resistance in parallel of same value, R1, R2, R3, 10k 10k 10k, by the way, k is a kilo ohm, that is 10,000 ohm. So 10k parallel with 10k parallel with 10k. If you do this multiplication, you will get 3.3k each resistance. That is 10k upon 3, and this was 10k upon 2. So basically, if there are n resistors, n number of resistors, right? R1, R2, R3, kind of Rn, and all of them are equal, which are equal to each other, then equivalent resistance is value of a single resistance R1 or R2, R3 divided by number of resistors in parallel. That's equivalent resistance. Tip number 2, what will you do if there are two resistance of unequal values, 10k 2k? So okay, 10k parallel 2k. Okay, you do this 10k into 2k divided by 10k plus 2k, and you do all this stuff, right? 12k and whatever is this value. Okay, but every time you are not going to do this. This is like a lot of calculations. So remember that whenever there is a high value resistance in parallel with low value resistance, like 10k is higher than 2k, right? So the equivalent resistance of this, the parallel combination of these two, is always less than the lower resistance. Remember that. So this R equivalent is going to be less than 2k value. It may be 1.7k, maybe 1.8k, you can calculate that, but it's gonna be always less than 2k. That's how you can remember. Suppose you have a combination of 100k and another resistor 1k, both are in parallel. In this case, the equivalent resistance is going to be less than 1k, because in a parallel combination the lower resistance dominate. Remember that. That's one shortcut. Let's talk about tip number 3. In this, suppose you have to calculate 10k resistance in parallel with 5k. If you want to do this simple math, you can rearrange this thing, and you know that parallel combination of two 20k resistances. If you want to do this, then what we can do is we can keep 10k as it is, while we know 5k is a parallel combination of two 10k resistances. So we can write 5k as 10k in parallel with 10k, and in this way you can find the R equivalent, which is 10k divided by 3 of those, which is 3.3k. This is kind of easy computable equivalent resistance method, intuitional method, where you can just make sure that it's easy to calculate the equivalent resistance. It's really handy method. It allows you to analyze circuits quickly in your head. Every time you don't need to go to the calculator or computer and calculate the value, right? So that's it about series and parallel resistances. Next thing we will talk about, some naming conventions. So we saw that R is equal to V by I, right? V is equal to IR. We have seen V is equal to IR, right? But some people like this equation little different, where they put it as V is equal to I over G. So basically I is equal to GV, where G is conductance and G is defined as 1 over R. That's a conductance. So conductance is opposite of resistance, so it's 1 over R. So that's why V is equal to I over G. Sometimes some people do this in circuit design industry. So just to let you know, if you see something like this, don't get scared. Then let's talk quickly about power in resistors. So we know that power in any circuit is always V into I, and the similar thing apply for the resistor. Suppose there is resistance here of 10 ohms. There is some current going to the resistance of 1 ampere, and if you want to know the power, what you will do is V into I. Oh, but we don't know what's the voltage here, but we know V is equal to IR, so I into R for V into I, which is I square R. That's equal to 1 amp square into resistance of 10 ohm, so that is 10 watts. So this is a 10 watts of power. That's how you calculate power, and the power in the resistor is dissipated as heat. Okay, so this power, the resistance express this power in the form of heat. So again, from that you can guess that each resistance or each resistor has different power ratings. They have different power rating. 1 watt resistor, high power resistors, 20 watt resistors. We'll see these actual resistors, of course their pictures, maybe in the next lecture. I think I will stop now, and in the next lecture we will see more about the resistors. We will see the different types of resistors, how they look, and also we'll see how to measure a resistance. We'll see that in the next lecture. Thank you.